Hi, welcome back down. We're going to talk about permutations today. This is 11.2. And a permutation is an ordered arrangement of items, and it's very specific. Each item is only used once. All right. First condition, each item is only used once, and the order makes a difference. Okay, we have to keep these two things in mind, talking about permutations, okay? I'm going to go straight into it, and we're going to look at a couple examples. It's pretty straightforward, but I'm going to go from example 1, and this is on page 117 of your workbook there, okay? And we have 6 performers are to present their comedy acts on a weekend evening, okay? So we have 6 performers. All right. And how many different ways are there to schedule their appearances? Okay. So each of these 6 performers gets their time to go ahead and schedule their appearances. So when we go ahead and schedule the first appearance, we have the choice of all 6 performers, so anyone can go first. Okay. When we have to choose our second performer, one person has already gone. Okay, so now we only have the choice of 5 performers left. One has already gone beforehand. When we go to our third performer, 2 performers have already had their performance done. So now we only have a choice of 4 of them left. Okay, and again, when we go to the fourth performer, 3 have already performed. So we only have 3 more left to pick from. When we go to the 5th performance, 4 have already gone, 2 are left. And by the time we hit the 6th performance, there's only 1 person to choose from. The only person that hasn't gone is the one that needs to go ahead and go. Right? And so what we want to do is we just want to multiply all these things together. Okay? And there's 700 and different ways we could go ahead and schedule their performances. Okay? So if we have a choice of anybody, all we have to do is go ahead and pick them, put them in their time slot, and be done. But we have 700 and different ways we can go ahead and do that. Okay? So now let's go ahead, and I want to look at example 6. Okay? And I have a camp counselor and 6 campers. So 1 counselor, 6 campers. Okay? And they are to be seated on a picnic bench. And we want to know how many ways this can be done if the counselor needs to sit in the middle. That kind of makes sense. All right? And a camper who has a tendency to engage in food fights must sit to the counselor's immediate left. Okay? So here we could think of it like this. I have a total of 7 people. Okay? 7 places. The counselor must sit in the middle. So right here in the middle should be our counselor. Okay, so that's only one choice. The counselor must sit there. To the counselor's left is the camper that likes to make food fights. That also only gives us one choice. Okay, so that camper must be seated right next to the counselor. Now, of those 2, okay, so we had 7 people. We already seated 2. We have 5 more that need to go. And they can go in any place. So I have a choice of 5 campers here. Once I use another camper, now I only have a choice of 4. Now I've seeded 4 of them, so I'm only left with 3, then 2, and then 1. Okay. And now that we have restrictions on the seeding, we want to go ahead and multiply these together. Okay. So 5 times 4, multiplying by 2 ones, that's not going to change anything. 3 times 2, and then another 1, that's not going to change anything. And I end up with 120 different seating arrangements with the restrictions on these 2 people. Okay, so there's a lot of different examples on this. Most of them are straightforward. Some might be a little tricky, but feel free to reach out to me if you struggle with any of the other examples that are on here. Another part of this section, you notice that we all had a lot of numbers in order. Okay, so when we did example 1, we had numbers that were being multiplied in descending order all the way to 1. Okay, and so when that happens, we have something that's called factorial. Okay, and if you have a TI-84 or something similar at home, okay, the factorial just looks like a exclamation mark. Okay, and you can find this factorial too if you go to math. Okay, and arrow, use your arrows and go ahead and arrow to the left to PRB, probability. Right, and if you look at number 4 in there, there's your factorial. You go ahead and hit that. Okay, and that will give you the factorial tool. All right, you want to put your number first. So if I wanted to go ahead and do this, if I wanted to do, let's say, the one that we had started off with 6. Okay, so that would be 6 factorial. Okay, and 6 factorial, I would hit the 6 first. Sorry. Okay, hit the 6, go ahead and hit my math key, arrow to probability, hit my number 4, hit enter, and that 6 factorial is equal to 720, which is the same thing as multiplying 6 times 5 times 4 times 3 times 2 times 1. Okay, so if you do not have a TI-84 or a calculator that does factorials, you can still do this and end up to the right answer. So don't feel that because you don't have one at home, you can't do this. It's totally doable. Okay, so let's go ahead and look at example 7, where we're just talking about factorials. All right, and I want to evaluate each expression. So I have 9 factorial over 6 factorial. And I'm going to show you a little trick for those of you that don't have a scientific calculator and can't use the factorial tool. Okay, 9 factorial is 9 times 8 times 7 times 6. And 6, you got 5, 4, 3, 2, and 1. Okay, the denominator is 6 times 5 times 4 times 3 times 2 times 1. And anything that's equal in the denominator and the numerator can be canceled as long as everything's being multiplied, which is totally true. So I can cancel out all the denominator and only have 3 numbers left in the numerator. Okay, which is 9 times 8 times 7, which gives me 504. Okay, another way to think about this, I can go ahead and rewrite this as 9 times 8 times 7 times 6 factorial, because I know the rest of it is 6 times 5 times 4 times 3 times 2 times 1, and this is divided by 6 factorial. Those are going to cancel in themselves, and I still end up with 504. Okay, so there's several different ways to go ahead and approach this. All right, I'm going to show you one more of these. So part C of example 7 is 100 factorial divided by 99 factorial. Okay, that means I have 100 times 99 factorial over 99 factorial, which gives me just 100. I didn't even need a calculator for this. Okay, so factorials are pretty easy to do. They're really helpful when we go ahead and look at page 120. And we're talking about permutations of different ways. Okay, so if I have our items chosen, from n items, so n items is what I started off with. All right, we write this as P and choose R, which has the number of items factorial divided by the number of items minus the ones we chose factorial. Okay, so let's go ahead and look at example 9. And we have a corporation has 7 members on its board, so my N is 7 total. 7 board members. All right. And in how many ways can I elect a president, vice president, secretary, and treasurer? Okay, those 2 things, those are 4 different positions. Okay. So how I would set this up, I have P of 7, choose 4, 7 factorial over 7 minus 4 factorial, okay, which is the same as 7 factorial over 3 factorial, okay. You can put them in a calculator if you have a calculator. If not, do the little trick, 7 times 4, or 7 times 6, sorry, let's erase that. Let's do this right. Times 6, times 5, times 4, times 3 factorial over 3 factorial, okay? Or you can put it in the calculator and you'll get 840, okay? So this is if we're taking items, and every time we take an item, one goes away. Okay, so every time we take an item, we only are left with what's left. Okay. Sometimes we can take duplicate items. Okay. So an example of this would be if we want to take green balls. Okay. And we have red balls, and we have blue balls. Okay, so every time we pick a ball, we notate it. So if let's say I reached in, picked a green, I go ahead and I put that green back. So I could possibly choose the green one again. And every time I pick a ball, I go ahead and put it back. Okay, so I can keep picking the ball several times in a row. All right. So when we have identical items, or we put an item back, okay. So this is our new formula. So we have the number of items we have, okay, where there's so many duplicates. So I have several duplicates of the green ball. So we're not putting, we have several duplicates of the Q, of the R, and however many items we have. All right. And I'm going to go ahead and do example 11 to see how this works. In how many ways can the letters of the word osmosis be arranged? So okay. And osmosis has 7 letters total. So that's our N. Okay, I have an O. How many times do I have an O? Twice. Okay, I have an S's. I have 3 S's. And then I have 1 M and 1 I. Okay, so this is what it's going to look like. All right. I'm going to have my 7 factorial divided by, okay, I have duplicates of my 2, so we're only looking at duplicates, and duplicates of my 3. Okay, the rest of them I only have one choice. If you want to think of it as a 1 factorial, you can, but that's not going to change anything. Okay, when I multiply this gives me 840 choices for 7 divided by 2. Okay, so what I did is I canceled out the 3 factorial. Okay, and I end up with 420. Okay, so I wrote out the 7 times 6 times 5 times 4 times 3 factorial and then canceled out the 3 factorials. Okay, so again, if you have any questions, that's 11.2. We'll come back for 11.3. Again, reach out to me if you have any questions.